Let us analyze the crash of Air India flight 171.
On the crash of flight 171 of Air India, which took away 241 lives, leaving only one survivor, a 38-year-old on board in seat 11 Alpha. So the pilots, looking at the timelines, the pilots knew what was wrong. The aircraft took off at 1:39 p.m. and the crash happened at 1:40. So in aircraft, things happen pretty fast. Within 60 seconds, a lot happened. So many things happened within 60 seconds. Right, so the pilot made a mayday call right before rotation. The rotation is the point where the aircraft is very light and getting ready to lift off the ground. That is when they realized something was wrong. So they made a mayday call. So this tells me that the pilots knew what was going on. They knew something was wrong. So they were staying on top of the game. They were staying ahead of the aircraft. So they knew something was wrong. Just that they were at the point of no return. In this case, the only corrective action is to alert ATC that something is going on, and then they will circle back to land. So at that point, you cannot turn back. Your aircraft is almost past midway of the runway, and then your only option is to declare emergency and then try to circle back to land so that you'll be able to diagnose exactly what is going on with the aircraft. And that is, I think, what the pilots were trying to do. 4 fundamentals of flight are lift, weight, and drag. And lift, weight, drag, and thrust. Thrust is moving you forward, and weight is also a critical factor because at that point the aircraft was the heaviest it can be on the runway. And with this aircraft, I will not say density attitude has effect. Density attitude, can play a little part, but with this type of engines, density attitude, or the temperature of the air molecules in the atmosphere has negligible effect on these powerful engines. We are talking about Genex 1 Bravo, which is capable of producing 75,000 pounds of thrust. So in this case, both engines are capable of producing 150,000 pounds of thrust. So density attitude has negligible effect on these type of aircrafts. 650 feet, as the aircraft was climbing, the aircraft lost thrust. The loss of thrust also affect lift because whenever you have a lot of forward motion in the air, you can always sacrifice some of your speed to gain altitude or to stay or maintain your altitude to stay in the air. In this case, the engines, the loss of power in both engines was very, very, very critical. So the pilots, as the nose of the aircraft trying to go down, the pilots were trying to hold back pressure to maintain altitude or to keep the aircraft in the air. Right. What happened was, because the pilots knew what was going on, it simply tells all of us that as the aircraft was getting airborne, there were alerts, there were alarms, there were warning signs at the flight deck telling the pilots that something is wrong. That is why they made the mayday call during rotation. Losing electrical power means that you are losing your engine power, means that you are losing your integrated drive generators. There are 2 IDGs, one on each engine, that produces electrical power for avionics and equipment that is being used to fly the aircrafts. Immediately you lose your engines, then the ram air turbine on the side of the aircraft will deploy to only provide enough power for the essentials equipment that is needed to fly the aircraft. So I really applaud the pilots for realizing earlier on that something was wrong. So This can be something as simple as mechanical issue. It can be a fuel contamination. It can be that somebody put the wrong oil in the engines. Right. So this is my analysis on the crash. This is myself inside the horizontal stabilizer of a Boeing 767 during a troubleshoot for hydraulic leaks. This is myself at the flight deck of a Boeing 747, during routine updates of avionics. This is myself working on the Boeing 767 CF6 engine. This is myself in the avionics compartment of a Boeing 777. So I have a lot of experience working on these aircrafts.
I have a bunch of experience working on these type of aircrafts and these type of engines. And what I can see is it can simply be a mechanical failure. Machines also break down, they wear and tear with time. So it can be a simple mechanical failure, or it can be that somebody put a wrong engine oil. It can also be that there are blockages in the fuel and engine lubricating system hose and lines. But during the takeoff phase is when the aircraft is heavy. That is when you need all your power for takeoff. So during this phase of the flight, a lot can happen. That is the only phase of the flight when you need all your available power, especially in these commercial jet airliners. This is when you need all your power. During the cruise phase, you are cruising about 75% power. During the landing phase, sometimes you don't even need the power to land. You just bring the power out and you come down and then you flare and you land. So during the incidences happening in aviation, most of them are happening during the takeoff and the landing phase, because during the takeoff phase you need your full power. This is when the aircraft will be exposed if something was wrong that was not corrected in the past. So if somebody made a mistake securing the fuel filler cap, somebody made a mistake securing the engine oil filler cap, this will be exposed during the takeoff phase because you need full power. Right. Loose hose, loose fuel lines, blockages in fuel hoses and lines will all be exposed during the takeoff phase of the flight. Right.